Welcome back. Today we're going to look at section 4.2. We're just going to talk about concavity. We're focusing on concavity. And concavity is going to come from the second derivative. So when we talk about concavity, we talk about the curvature of a function. So I go ahead and draw out maybe a function up here. And we go back to our nice little cubic function. And if we look at the curvature of this, if you notice here, from left to right, this portion in here is opening downward in a downward manner. We call this concave. You can't read that a whole lot, can you? We call that concave down because it opens down. It's curved down. And this other part, the part here on the right side of it, if we go kind of like this is kind of concaved up, or it's pointing up, so we call it concave up. And that's what we're going to talk about today, is being able to find where is that curvature, how is that curved pointing, maybe, if you want to think of it in that manner. Is it concave up? Is it concave down? And again, that's coming from our second derivative. If the second derivative is greater than 0, so if it's a positive value, then it's going to be concave up. If it's less than 0, it's going to be concave down. When it's equal to 0, we'll see that in a couple of videos from now, we call that a point of inflection. And that's where it's going to change from being concave down to concave up, or concave up to concave down. Points of inflection will be later on as we get into it. So how do we find concavity and the steps that we go for it? Well, the first thing we're going to do is find our second derivative. We're going to set that equal to 0 and where it's undefined. Remember, we talked about this undefined where we have it where our denominator is equal to 0. And our numerator is equal to 0 when our second derivative is equal to 0. These are possible points of inflection. Again, we'll talk about those later. Those are possible points of inflection where we change in our concavity. Then we're going to create a test. Just like we did our increasing, decreasing intervals, we're going to do a second derivative test for concavity. If it's greater than 0, it's going to be concave up. If it's less than 0, we're going to concave down. So I got just a couple of examples today. It's not going to be too miserable. Again, we're just looking to see where that concavity is, or what the concavity is. Eventually, we're going to put it into being able to graph a function. So the first thing we're going to do is go ahead and find our second derivative. In order to do that, we're going to find our first derivative first. We have x times x minus 4 to the third. Biggest thing here is getting our derivatives correct. So we have product rule. So we have x times, here we have a chain rule, 3 times x minus 4 to the second times 1. So that we're going to add x minus 4 to the third times 1. And there's a couple of ways you can go about doing this, and it's quite up to you. What I normally like to do is go ahead and simplify by factoring out any common factors. Makes our life a little easier, maybe. So we have x minus 4 squared in both terms that we can go ahead and factor out. And that's going to leave us with 3x on the left side and an x minus 4 from the right side. So that's going to give us x minus 4 squared times 4x minus 4. And that's where I would like to go ahead and find my second derivative, because again, we have a nice product rule here. We have x minus 4 squared times 4x minus 4. So again, we have product rule, we have x minus 4 squared, derivative is going to be 4. To that, we're going to add 4x minus 4. Derivative here, we have a chain rule again, 2 times x minus 4 to the first times 1. And again, I'm going to go ahead and clean this up just a little bit. My 4x minus 4, I can take a 4 out of that if I wanted to. And I kind of want to because I have a 4 over here, don't I? So I have 4 times x minus 4 to the first. And that's going to be multiplied to what I have left over. So my x minus 4s. My 4 and x minus 1, that went, or my 4 and my x minus 4 went out. So I have a 2 times an x minus 1 left. I'm going to go ahead and clean that up just slightly a little bit more. So I have 4x minus 4. Here I can multiply my 2 through. So I get 2x minus 2. Add on my x, so I get 3x. And then I get 4 minus 2 gives me negative 6. I see that I could take a 3 out of 3x minus 6. If you want to do that, you can. Might as well go ahead and do it since I saw it. If you don't, it's okay, because ultimately what we're doing is set this equal to 0. might help as we plug in some values, our test values, but it really is up to you on if you want to take that 3 out or not. So I get x equals 2 and x equal 4. So I'm going to do my test, my intervals. I'm going to again start at negative infinity. I'm going to come all the way to my first critical value, which is 2. And I'm going to work my way up until I get to infinity, just like I did with my increasing, decreasing intervals. I'm going to find test values again on this interval. So I'm going to go, oh, I can do 0, can't I? 0 and 3 and 5. And this time I'm looking for the sign of the second derivative test. I'm going to plug 0 in. Again, I'm looking at only the sign of it. Is it positive? Is it negative? Well, if I think about 0, that 12 is always going to be positive, isn't it? So again, I can go ahead and fill that in, positive. If I plug in 0 here, 0 minus 4, that's going to give me a negative. If I plug in 0 here, 0 minus 6, that's going to give me a negative as well. So that gives me an overall positive value. If I plug in 3, I get a negative. If I plug in 3, I'm going to get a positive. So I get a positive times a negative times a positive, which is a negative. If I plug in 5, I get positive, and I get another positive. And that gives me a positive. So I'm going to be concaved up. I'm going to use my arrow there on this interval. And I'm going to abbreviate concave with a C. I'm going to be C down on this interval, and then concave up. Again, positive to concave up, negative is going to be concave down. So again, we could write this as concave up on these intervals, negative infinity to 2, union 4 to infinity. And I'm concave down on the interval from 2 to 4. Again, we're not going to have brackets because we're going to include those values. They're going to be in parentheses because, again, we can't be concave up and concave down at the same point in time. And when we change, that's where we're changing that concavity, we can't have that same value there. Now, one last one here, a cubic function. Again, we're going to keep it nice and clean and simple today with our polynomials. We're going to find our first derivative, so we get 3x squared minus 6x minus 24. And then our second derivative is going to 6x minus 6. I'm going to set that equal to 0. So I get, well, I don't need 6 there, do I? I get x equal to 1. So in this one, I only have one interesting point, my possible point of inflection, as we talk about later on. Right now, we're going to do our intervals, negative infinity to 1, and then 1 to infinity. Values that I want to test, from negative infinity to 0 to 1, I can do 0, and 1 to infinity, I can plug in 2. Again, I'm looking at the second derivative sign. If I plug in 0, 0 minus a negative, minus 6 gives me a negative. 12 minus 6 gives me a positive, so I'm concave down and then concave up. Again, that makes sense to me since I know that I have a cubic function here. And a cubic function, this isn't going to be in general, but maybe it looks something like that. So I know that I'm concave down to start on the left portion of it and then concave up the second portion of it. And I know that's going to change here when x equals 1. So I'm going to see that point where it changes from concave down to concave up right there. And that gives you an idea of concavity and how to find it. We'll eventually be able to apply it and be able to come up with a nice graph of a polynomial and rational expression. Good luck and enjoy!